Hello friends, welcome to Civil Ideas. Today in this lecture I'll talk you about the stress strain curve of concrete and steel. So let's get started. What is concrete curve? As you can see in this curve, there are three types of curve. The first one is characteristic curve of cube of 150 mm 1 into 150 mm into 150 mm. And the second curve is the characteristic curve of structure. And the third one is the design curve. Now we know concrete resists only compressive stress. To a strain of 0.02, the strain will be parabolic. Then the slope becomes 0 up to a strain of 0.0035. Here you can see up to the strain of 0.002, all the three curves are parabolic. But when we design for full structure, the compressive strength get reduced due to influence of size. Now here's the thing: when we design a structure, then the cascade curve of structure is reduced. IS 456-2000 suggests that characteristic strength of structure, I mean to say the structure it will be a building, will be 0.67 FCK. Now, according to limit state method, we have to provide partial safety factor of 1.5. Now, if we divide 0.67 FCK by 1.5, we will get 0.45 FCK. Now, when we design the RCC structures, for concrete we use 0.45 FCK for design stress, and the ultimate strain we take for concrete is 0.0035. Now steel curve. Here you can see there are two curves. The one is for 1 mile steel and the second one is for HYSD, high yield strength steel bars. In steel there is nothing like size of steel as in case of concrete. Design curve is obtained by dividing partial safety factor of steel, which is 1.15. If you divide Fy by 1.15, we will get 0.87 Fy, which is the design stress. There is no specific yield point for HYSD bars. Stress in HYSD bars corresponding to proof stress is 0.002, is known as yield stress Fy. Now this line, when you draw a line parallel to the curve, I mean it's the cascade curve, this the line where it bisects, and if you draw a line it will give you the ultimate stress. In design problem we use strain is equal to 0.002 0.002 plus 0.87 Fy plus 0.87 Fy. IS code specifies a uniform criteria of all grades of steel. In limit state method, yielding of steel at ultimate limit state. If steel yield at ultimate limit state, then the failure will be ductile in nature. Now, there are some important points you should remember. If you compare curves of both steel and concrete, in concrete we apply partial safety factors for all stress levels, in all stress levels. But in case of steel, we apply for in elastic region only. Now, the IS code it is given that the concrete modulus of elasticity EC is equal to 5000 FCK megapascal. In the above equation, EC is directly proportional to FCK. That means concrete modulus of elasticity is directly affected by grade of concrete. Concrete modulus of elasticity depends upon variation of compressive stress. In case of steel, modulus of elasticity is constant, which is equal to 2 into 10 to the power of 5 Newton per m square. In steel, we apply partial safety factor for non-linear region of steel only. Now we have a question in all of our mind that why modulus of elasticity of concrete is different from different grades. Now we know that stress strain curve of concrete show non-elastic and non-linear. Now in this graph, when we give a loading to a concrete cube, and when we unload the cube, after unloading it doesn't follow the same path. See, it goes like this from the origin, but when you unload there is a gap. The strain is increased after it meet at some point after from the origin. Now after unloading, it doesn't follow the same path and hence concrete is unable to achieve its initial stage. There is a gap, that's why hook load doesn't directly applied. Initial portion of the curve is linear. At the initial stage, you can see this is the initial, this is linear, due to which the stress and strain is directly proportional and it obeys Hooke's law. Now, what is the types of strain in concrete? There are two types of strain, short-term elastic strain and long-term elastic strain. In short-term, the short-term modulus of elasticity occurs due to short-term elastic strain and effective modulus of elasticity ECE occurs due to long-term elastic strain. Short-term elastic strain are due to instantaneous load is applicable on the concrete. That means when there is sudden load applied on the concrete structure, short-term elastic strain occurs. Long-term elastic strain is due to creep and shrinkage. Now, we already, as in our previous slide, I told as per IS 456 clause number 6.2.3.1, the empirical formula is EC is equal to 5000 root FCK, which is short-term modulus of elasticity. Now, for example, take FCK is equal to 30 megapascal or 30 Newton per mm square. Put 30 in this value. Now, 5000 into root over 30 will give you 27.39 into 10 to the power 3 megapascal, which gives you the short-term modulus of elasticity. Now, to find the effective modulus of elasticity, ECE is equal to EC divided by 1 plus theta. Now, what is theta? Theta is nothing but creep coefficient. Now, here are the three parts. After 7 days, the creep coefficient will be 2.2. After 28 days, it is 1.6. And after 1 year, it will be 1.1. Now, if a concrete already casted, after you want to find its effective modulus of elasticity after 28 days. Now, after 28 days of concreting, put theta is equal to 1.6 in the above formula. You will get the effective modulus of elasticity is 10 into 10.53 into root 10 to the power 3 megapascal.